Hi, we're back for part 2 of lecture 4 on real GDP and nominal GDP. And so last time we did the two nominal GDP numbers, and then we did the real GDP numbers using year 1 as the base year. And then we took the percent change of these numbers and we got 43.33%. And now we're going to pick year 2 as the base year. On the exam, I would instruct the students to pick either one year or another year as the base year, and whatever year I pick, those are the prices you're going to use to do the calculations. And so in this case, if year 2 is the base year, then we're going to use the same production numbers that existed in year 1 and the production numbers in year 2, and this time we're going to weight them according to the prices that existed in year 2. So in year 2, every chair was valued at $400 per chair. And so we use the same prices in both years, year 1 and year 2. And then the price of each gallon of milk was $5 in year 2. And so we take the 10 million shares, we times that by $400. That gives us $4,000 million. And the shares cancel out. And then we have 100 million gallons at $5 per gallon. That's 500 million gallons. Gallons cancel out. Add them together. The GDP for year 1, real GDP for year 1 using year 2 prices is $4,500 million. And down here, we do the same calculations here. So we have our 50 million shares. Whoops, made a mistake. This is 400 million. Sorry, $400. Times 50 million shares, and these are per chair, and this is $5 per gallon. And so we have 15 million times 400, that would be $6,000 million. And then 100 million gallons times $5 per gallon is 550 gallons. 550 million dollars. Got to keep my units straight. Always think about your answers to make sure they make sense. Chairs cancel and gallons cancel, so it's all going to be measured in dollars. And then we're going to take the percent change. And again, these numbers, before we do the percent change, again, these numbers going from 4,500 to 6,550 is now a fair comparison because they're weighted in the same prices for all the units of production. So down here is our simple equation for percent change in real GDP. You take the current year, what's the year you're going toward, in this case it's year 2, subtract from that the real GDP from the previous year, which is year 1 in this case, and then divide by the previous year, which is year 1. And so we're going to take the 6,550 million, well the millions are going to cancel out, so just leave it at 6,550 minus 4,500. Divide by 4,500, and then times by 100. And by doing that, we get 45.56%. 45.56%. So this minus that will give you the number here, the difference. Divide that by 4,500 times 100. If I did my math correct, that should be 45.56%. And so we have two different numbers here for percent change in real GDP, which creates a problem. You may ask which one is correct, and the answer is they both are correct. So the answer is, so now the question becomes which one do we use? And the answer is we can use either one. And so what happens here is that we have an economic problem as well as maybe a political problem. What we can have is that by cherry picking a certain base year, you can actually make the percent numbers look higher or lower. And if you're running for re-election, maybe if you're a presidential candidate and you want to make the economy look better, you can direct the Bureau of Economic Analysis to pick a certain base year that would make the numbers look higher in terms of percent change increase. So the question is, why does this happen? Why do we have two different percent changes? And the answer is because we're using different fixed weight values with different base years. So think about it. How can we, again, cherry pick the numbers so we can sort of tip the scale and make things look better? Well, we have two goods here, and share production went from 10 to 15 million shares, or sorry, 10 million shares to 50 million shares. That's a 50% increase. Went up by half. Milk production went up by less percent. It went up from 100 million to 110. A 10 million increase from 100 is a 10% increase. So it looks like if we can make shares look more valuable, weight them higher, we can actually make real GDP increase or look like it's increased more. And so down here, look at the two choices we have. We have year one, and so we have prices of $200 per chair and the price of each milk. Well, 200 to 4 is the same ratio as 50 to 1. Divide 200 by 4, you get 50. And so these prices here are going to weight each chair 50 times as much as each gallon of milk. Can we do better? We'll go to year two. In year two, we can do better. It's 400 price for each chair divided by $5. 400 divided by 5 gives us 80. And so 4 to 5 is the same ratio, proportion as 80 to 1. So by having year two prices, we can weight each chair 80 to 1, 80 times as much. So if we can pick these prices, we can make chair production look greater, which we want to do because that is the one that had a higher increase in production. So give this a little extra boost. We can make the percent change in real GDP higher. And again, so by picking year two, we give higher weight to our chair production, which is higher than milk production. And so again, we can tip the scale in favor of chairs and get a higher percent change. So this creates a problem here. Again, this politically can be abused by politicians, but if you, even if everyone's being innocent and no one's trying to abuse the numbers, it still creates an economic problem because now whenever the Bureau of Economic Analysis picks a new base year, which they do not because they're trying to change or they're trying to manipulate anything, it's because they're trying to bring numbers closer to people living now, and we understand the value of a dollar now than it was maybe 50 years ago. And so it just makes the numbers more meaningful to people living in this year currently. And so they do this every once in a while. And so by doing this, they're going to be rewriting economic history. And the Bureau of Economic Analysis recognized this back in 1996, and they decided to come up with another way. And what they do now is the same thing we just did. They do the calculations using year one as the base year. They do the same calculations using year two as the base year. Sorry, I had to find this piece of paper. So instead of worrying about which year to pick the base year, the Bureau of Economic Analysis just says, you know what, just compromise, just take the average. And so that's exactly what they do. They do the same calculations we just did using the 2 years next to each other. So for example, they would do the same calculations, say for 2019, using 2019 as the base year, comparing that with 2020, and then they would use 2020 as the base year and compare that with 2019. They would get two different percent change numbers, and then they take the average. And the average they take is called a geometric mean, which means they multiply the two percentage numbers together, and then you take the square root. Why is that a better way than simply taking a simple average? I'm not quite sure. The statisticians at the Bureau of Economic Analysis have a reason for that, and that's fine. This is just another way to take an average. And by doing this, they chain them together, and this is a process known as chaining. And so by taking the average, they have tied them both together as a chain. And so we call this a chain type of real GDP percent changes. And so here we have the number for year one as a base year, 43.33%. We did the calculation. We did the same thing to get 45.56%. So multiply them together and take the square root, you come up with 44.43%. And this now becomes a number that forever is going to represent the percent change in real GDP from year one to year two. And no matter what year you pick as the base year later on, this number will never change because the process of chaining them together is never going to deviate. And so that number, again, the number is going to be there forever. until the end of time, it's going to be 44.43% from year 1 to year 2, if year 1 and year 2 were real years in terms of calculation. So you have 2019 to 2020. They'll chain them together, and whatever number they get for percent change is going to be the number that's going to be there again 10 years from now, 100 years from now, 1,000 years from now, assuming we're still here. Okay, I'll stop there. And the last topic we're going to talk about in terms of real GDP and inflation is going to be the GDP deflator.